with me are my friends Urvi, Stuti, and Rohit, of course, and Rohit is presenting today. Through Launchpad, we usually have talks every month. We didn't, of course, because due to this whole COVID thing for the past couple of months, but we usually have talks in person. We took this opportunity now to start online so that people can join no matter where they are. Otherwise, we were in Pune, specifically in Kothur. But now, no matter where you are, you can join us. It's free. We specifically want more school students to join. This is primarily targeted at school students. We'll talk more about this later. But yeah, I'm really glad that all of you are here today. And I'll just hand it over to Rohit. I think most of you have seen the ads, so you kind of know about us, you know about Rohit. But Rohit can very briefly introduce himself again, just to kind of put us all on the same page. Yeah, Rohit.
Thank you. So, welcome everyone. Welcome to Taxi Ride Through Computer Science. I'm Rohit Aute. I'm a computers engineer. Almost a computer engineer. My final year exams are not yet done, unfortunately. You probably heard that in the video, in the promo video as well. And I'm also a Microsoft student partner. So this is like a community outreach program by Microsoft, and I'm expected to like share my knowledge and talk about technology with people, with the community within my community basically. So this is the first ever event that I'm doing, and I'm really excited for this. Uh, so shall we get started? I think we should get started. I'm not going to hear much from you, I guess. Most of you. Okay. So before we begin, I want to set up some ground rules. Okay. I want everyone's mics to be turned off because it can get really chaotic if you just hear someone's background noise or something. So the first thing I'm going to do is mute you all, and I would really appreciate if you could keep your microphones on mute. I would really appreciate that you start off your camera. I would love to see your faces. I would love to see your reactions. That would really make this, feel as lifelike as possible. Since we were unable to do this in person. Uh, since you're all on mute and I can't really see you, here's the thing. I keep asking questions like, do you understand? Or throughout the session, I will be asking questions like, do you understand? Do you follow? Or, does it make sense? So I would love if you guys could like respond with something like this, like yes or no. Is that fine? Is it cool?
People can raise their hands. Yeah.
Okay.
Yeah.
Oh, yeah. And you can even use the
Yeah.
raise hand option if you like. That would be amazing. Okay. So yeah, that's one thing. And yeah, I think someone asked in the chat that whether you'll be able to interrupt me and ask questions. We would really love that, but since this is an online format, that could get really chaotic. So what I'm going to do instead is I'm going to stop after a few slides, every few slides, and we'll take a few questions, like a couple of questions. And at the very end, we'll also have a Q&A session. So hold on to your questions. If I'm unable to answer them during, in between the slides, I'll definitely try and answer them in the question and answer section. And finally, even if we run out of time for Q&A, I'll be sharing my contact details so you can reach out to me after the session. I would absolutely love to help you out, and we can have a conversation about this. So cool. Yeah. Okay. I guess. Awesome. Yeah, I'm seeing some hands raised. That's good, I guess. So let's get started. Let's start this this little journey. So the agenda for today is that I want to show you, I want to give you an introduction to computer science and tell you what it's all about. I'm not going to waste too much time on these slides. So yeah, I'm going to talk about computer science. I'm going to talk about all of the subfields in computer science, and we're going to do this by taking the example of popular apps like Uber and Ola. So these apps are a good example of, computer science, pretty much every field of computer science working to make something possible. So when you take a taxi ride, behind the scenes, almost every major sub branch of computer science is at work. So this is a good opportunity to look at the landscape of computer science, to look at everything it has to offer. So we're going to do that, and at the very end, we'll of course have a Q&A session. Now the motivation, I don't know how many of you saw the promo video, but our major motivation here at Launchpad is that computer science is a highly neglected field in Indian schools. It's not taught at all. As far as I can remember, I was only taught HTML and like 30 minutes of Q basic, and that's about it. I would have really, I think I would be in a very different position if I had learned computer science back in school. And our country produces so many computer engineers every year. Our IT industry is huge. So isn't it kind of sad that computer science is still not a big deal in schools? So that's kind of what we are trying to change here. We want people to know about computer science. We want people to know what it's about before they take it up as their engineering course, and we want them to know that it's not just programming or um, just a means to get a job, or just to just building apps. It's far, far more than that. It's a very beautiful field, and we want to develop curiosity about it in young minds. So that's it for the motivation. Okay. Yeah, let's begin our ride. Okay, keep doing this. Cool? Ready to hop on? Kai yaar, two people are raising their hands. Come on, 4, 5.
Yeah, we're ready. Let's begin our ride.
Very good, very good, amazing. So, okay, I'm gonna have to mute you all again. Thank you, but whoever spoke, thank you for that. So, you want to take a taxi ride? What is the first thing you do? You whip out your phone and you open the Uber or Ola app. So let's start from the app. This is probably one of the most popular fields of computer science. It's software development, making apps and making websites and stuff like that. So this is what a lot of people think of computer science as, just building software, and that's really not true. And you'll see how in this session. But let's start off with that. This is how you interact with Uber. You open up the app, you type in your location, your destination, you select the type of cab you want, and then you press that ride now button, and Uber and a taxi shows up at your doorstep. It's pretty amazing. So let's talk about what software development, what all comes under software development. You're obviously building an application that people are going to be using, so it's very important that the user interface is good. Look at this. This is a pretty application, right? It looks really good. It's slick, it's modern. So that's part of software development, user interfaces. And UX means user experience. So is the app intuitive to use? Is it immediately obvious what needs to be done in order to accomplish a task in this app? So this is quite a deep study on its own, and it's really interesting. And by the way, if you're just starting out with programming, this is actually really good. Not just programming, but computer science in general. This is a great way to get into computer science, because actually like writing some code and seeing it visually is really, really satisfying. The second thing that software development comes with is, well, you made that beautiful layout. It's all animated and it looks slick, but you also need stuff to happen when you interact with the UI. When you press a button, for example, when you press that right now button in Uber or Ola, the taxi should actually come to your place. So that's what happens with all of that is the business logic of your app. This is the actual stuff that happens behind the scenes in order to accomplish the task. Like, for example, when you click on that right now button, Uber has to talk to its servers. It's finding a taxi for you. It's calculating your ETA, or what else does it do? It calculates, it finds the best distance between your location and your destination. All of that needs to be done behind the scenes, and all of that comes under business logic. And if you're developing software, people don't use just the same phones. So people use Android, iOS, maybe you're building a website. So you're dealing with multiple platforms. So maybe you want to be an Android developer or an iOS developer or a web developer, or a combination of those, or maybe you want to develop for desktop, Windows, Mac, stuff like that. So software development is huge. This is one of the biggest industries as far as like the subfields of computer science goes. This is one of the most. This is one of those fields which has a lot of jobs, and it's fun. If you want to start off, this is really, really fun. So let's move on. You click on that right now.
Rohit, just a sec. I think people are having issues with their mic. There are a lot of people who are saying so in the chat. Could you just give us a minute so we can figure out what's going on?
Oh yeah, sure.
Uh, okay, a lot of people are like continuously like leaving and joining the meeting. Are you people having issues with your mic? Could you unmute yourself and tell us what the problem is? Can you not see? Can you not hear? What's wrong? Would you people like to unmute yourselves and just tell us?
You can just type in the chat. Okay. Thanks, Amol. Cool. Is anyone having issues?
Yeah, I think someone. I think Preetham was having issues. He left. I asked him to rejoin, and I think a couple of other people are continuously leaving and rejoining the meeting.
Oh yeah, Ria left and joined again.
Actually, many are unable to see the screen. Asmita says.
Wow.
Okay, so for the majority of the people, they're able to hear and see. So for those of you who are not able to, I think it's a connection issue. You might want to rejoin from a different device or try to connect to a stronger Wi-Fi if possible. Yeah, I mean, most people are not having any issues. So I think we'll have to continue. And also, we're recording this meeting, so we're going to put this up on social media. You can see any part you missed.
Yeah. This is all going to be online.
Right? Okay. I think we can go on then.
Okay. So you press that. You added all of the details like your location, the destination that you would like to travel to, and now we've hit that right now button. Now, as you all know, Uber needs Uber and Ola. These apps need internet connectivity. So why do they need that? Because the stuff that I talked about, all of the business logic that I mentioned, finding taxis and planning the best route for you, all of that stuff happens on Uber's servers. Okay, these are like computers owned by Uber, and all of this processing is done there. So your app actually needs to talk to these servers. And well, how do you do that? You do that using the internet, and you use computer networks for that. So this is another really vast and interesting field of computer science. This is I'll geek about it afterwards, but basically most apps need to talk to servers. It's not just Uber and Ola. Even if you're like talking on WhatsApp, your messages are going to the WhatsApp servers and then they're going to their destination. So you always need servers, you always need networking. And let's talk about how networking works in general. So your phone is generating some data, maybe this request that you placed with Uber for a taxi. This request, your phone will generate this request and it will send it over the internet. It will travel through multiple networks. It will go through your ISP. So maybe the ISP is your internet service provider. So maybe I'm using BSNL here, so my data is going to go through their servers, and then it will eventually reach Uber's servers after that. So that's typically how, and that's why it's called internet. It's traveling across networks in order to reach its final destination. And in order to make this happen, there are a few things that networks do. So right now, so let's talk about the first point here. Let's jump into the presentation. Networking involves study and design of standard protocols. So let me just explain this. This is because when you start learning about computer networks, this is going to be, you're going to be bombarded with protocols. There are a lot of protocols. So a protocol is just a formal way of communication. Like right now, I'm speaking to you in English. This session is in English. You're able to understand what I'm saying because you understand English, I understand English, and that's the reason this communication is well possible. If I was speaking in a foreign language, this won't make sense to you. If I was speaking in, I don't know, Japanese, very few people would be able to understand. So this logic applies here as well. Your phone and the server should have, they should know the protocol. They should use the same protocol. They should understand the same protocol. And for this reason, we have standard protocols. These are openly available. They are agreed upon by a huge number of people and companies, big companies. And then they are, they're part of every computer, pretty much every computer out there. And so does that make sense? You can, okay, does it? You can use the, okay, good. So yeah, that's one thing. So you need standard protocols. So some of the protocols are TCP, IP, HTTP, UDP. These are some of the very popular protocols that are used for communication. Next thing, I talked about how the app is sending a ride request to the Uber servers. Well, that entire piece of information won't go, as a whole. What networks typically do is that they break stuff down into packets. You may have heard of this word, internet packets, and each of these packets may travel over a different route over the network, and it's the responsibility of the network to like find the best possible route. It's really interesting, and you will be, if you take up computer science, you will be learning about how these things actually work, how data is broken down into packets, how these protocols work, how a network finds the best possible route, and it's pretty amazing. And if you're communicating, you also need to ensure that whatever you're sending, in this case, the app is sending stuff to the Uber servers. You need to be confident that the stuff is actually reaching the servers. You need some sort of guarantees about that, and even that, we have protocols for even that. So networking is amazing. We take it for granted every day. We use the internet, like it's a natural resource, but it's pretty amazing. It's a really, really complex thing, and the fact that it even works as well as it does, it's pretty amazing. So yeah, let's move on from networks now. So the app has now sent your ride request to the servers, but well, you want your communication between, the communication between the app and the server to be private, right? You don't want anyone snooping in on this communication. Like why? Like what if someone, I don't know, like you add your destination and someone is able to read that destination, because your data, when it's going over the internet, anyone can read it. So you don't want that to happen. You want privacy. You don't want anyone snooping in on your internet activity. And this is where cybersecurity comes in. So one of the major ideas in cybersecurity is that everything, all of the data that basically goes over the internet should be anonymous. And even if someone comes across that data, they shouldn't be able to do anything with it. And for that, we use something called encryption. And if you look at the bottom of the slide, let's say I'm placing an Uber request and I want to go to Deccan. For all of you who are outside of Pune, who are joining us from outside Pune, Deccan is a place in Pune. It's a pretty popular place. So let's say my destination is Deccan. That's what I've typed into Uber. Now, if I just send Deccan over the internet, and someone, maybe BSNL or maybe some attacker or a hacker or something, like a malicious person, is able to retrieve that, that's kind of dangerous, right? We don't want that. I only want my destination to be known between me and Uber. I don't want anyone else snooping in. So instead of sending Deccan as it is over the internet, what the app or what my phone would do is it will encrypt it. So what it will do is it will take this Deccan word and it will convert it into this complete gibberish here. Can you see this? This makes no sense, right? It just seems like a random sequence of characters. And now the app will send this over the internet. So even if someone were to get access to this, even if someone reads this, they won't be able to make any sense out of it, right? How the hell is anyone supposed to know that this means Deccan? So this is what actually travels over the internet, and when it reaches the destination, our destination in this case is the Uber servers. When this gibberish reaches the servers, it will be decrypted. So the Uber servers will again be able to read the original message, whatever it was. And this is kind of amazing, right? What do you think? This is pretty amazing. This is some really intense mathematics, and it's really interesting. This is called cryptography. This is partly computer science, partly mathematics, and it deals with how you can do these conversions. There are many ways of doing this, but this is the basic idea. This is basically how all of your online transactions and all your online communications, even this video call that we're having right now, is secure, and this is the basic idea. So we've sent a request to the Uber server, to Uber's servers, and it's secure. So let's move on to the next bit. Yeah, I've been talking about servers. Okay, I've been throwing this word around, but most companies these days do not want to manage their own servers. A server is basically a physical, it's just a computer, okay? It's a different kind of a computer, but it's still a computer. And if you're operating at a scale as huge as Uber and Ola, or or any big application, you need lots and lots and lots of servers. You need warehouses full of servers, and they're called data centers. But the thing is that it's very expensive and very tedious, and it's very difficult to maintain these data centers because you constantly have servers crashing. You need to keep all of those servers cool. You need to keep them updated. You need to keep the software updated. It's a pain in the butt. So wouldn't it be great if someone else kind of managed all of that for you, and you could just use the servers as it is, and without having to worry about building all of them from scratch? So this is exactly the idea with cloud computing. Cloud computing is basically using, or rather renting, someone else's server and using it as your own for a while. It could be for a while, could mean 5 minutes, an hour, a year, forever, whatever. So there are there are cloud providers, or cloud computing platforms like Microsoft's Azure is a very popular cloud computing platform. And what they do is, so what Microsoft has done with Azure is that they build these massive, huge data centers all over the world, and they build these and they stuff them up with lots and lots and lots of servers. And whenever companies like Uber or Ola, or even me, even if I need a server, I can just go on Microsoft Azure's website and I can say, hey, I want this server, I want this kind of a server, can just give it to me, and they'll provision a server for me, and I can start using it right away. And maybe I'm building like I'm a startup. My my startup is really small right now, but it gets really popular. I can just ask Microsoft to give me more servers. It's very easy for me. I don't need to worry about maintaining that data center and managing all of those servers. Microsoft will do all of that for me. I can just conveniently sit here, go on Microsoft's website, and just keep adding more servers. So it's cheap because you don't have to maintain a data center. Again, it's scalable. As I said, if you need more servers, you can just literally go on the website and provision more servers, and you'll have them in a few minutes. It's extremely convenient. I think that's quite evident by now, and it's extremely easy to use. So Ola uses Microsoft Azure. Ola runs on Microsoft's Azure platform, and Uber runs on something called AWS, which stands for Amazon Web Services. It's Amazon's cloud computing platform. So these are some of the big names. Even Uber uses Azure for some of their tasks. A fun example is again Netflix. I think everyone uses Netflix. Netflix runs entirely on Amazon Web Services. I think that's kind of cool. So yeah, what's the ratio on this? Are people following this? Let me see the numbers. Cool. Does anyone have any doubts at the moment?
What about Google?
What exactly do you mean?
Means does Google have its own cloud computing, or
Oh,
it
yes,
also
yes.
runs on?
Yeah, Google has its own infrastructure. In fact, Google has some of the most advanced infrastructure out there, and even they have their own cloud platform called Google Cloud Platform. So AWS, Azure, and GCP, that's Google Cloud Platform, are some of the big names in the cloud computing industry.
Oh.
Okay. Does anyone else have any questions?
What do you do when all of the server space runs out?
Okay, they basically that's a pretty good question. Even I thought of that, but that usually doesn't happen. These companies, they have massive warehouses, and it's very unlikely that you'll ever run out of server space. They always have more servers than the demand, so that they can give out servers.
But don't you think it's going to be kind of an unsustainable model for the next 50 years?
No, it's actually a pretty good model, because now everyone doesn't have to have their own data centers. They can just use a cloud computing provider. It makes the job easier. Instead of having everyone do the same job, only a few companies can do this rather tedious job, and others can just enjoy it. Others can reap the benefits of that. Okay, anyone else? Okay, someone on the chat is asking, is encryption the same for particular location all the time? Oh, no. Okay, Vedang, what I talked about was a massive oversimplification of what encryption is. It's it's a lot more complicated than that, and it's kind of beyond the scope of this session. But if you're interested, just I'll give you my contact details, and we can have a conversation about this offline. Cool. Okay, so shall I move on? Okay, I'm moving on. So that's cloud computing. This is again one of the hottest topics out there. This is a huge industry, and a lot of businesses these days are moving to the cloud. So yeah, next, this is one of my favorite topics in computer science. It's distributed systems. So I've been talking about, again, servers. I've been talking about servers, and Uber and Ola, these apps operate at such a huge scale that you can't run all of them at using just like one physical server. You need many servers. And this is what basically distributed systems are. Instead of having a single server handling all of your load, you distribute the load across multiple servers. Now, this seems like a rather intuitive idea, right? If a single person is like, if let's say we were lifting a car, and if obviously a single person is going to be unable to do that, but if we have like 10-15 people lifting the same car, it's going to be much easier, right? So this is kind of an intuitive idea. You're distributing the load, but it's easier said than done. This subfield has one of the most interesting has some of the most interesting problems, engineering problems that you can face. So and by the way, someone might say that, okay, then why don't you just build some more powerful servers? That way you can have just one really powerful server instead of having like 10 not so powerful servers. The problem is that there is a physical limit to how powerful we can make our computers. And even if there are huge computers, like there are mainframes from IBM and Oracle, but even they are severely underpowered. Even they cannot serve the entire load of Uber and Ola. And another scary thing about them is, what if that one server just fails? Your entire service will go down. So distributed systems are extremely important, and these are extremely common across these huge services like Uber, Ola, Google, Netflix, Facebook. Pretty much any huge site, they're running a distributed system behind the scenes. So let's talk about some of the challenges. If you decide to become a distributed systems engineer, these are the challenges that you'll face while building distributed systems, and these are really interesting in my opinion. So scalability. So I said that let's say you have one server, and it can do 1,000 things at a time. Now, if you have two servers, does that mean does that mean your system will be able to do 2,000 things at the same time? That's not the case. Just because you add more servers doesn't mean you get that times the performance. So if you have two servers, it doesn't mean you'll get 2 times the performance, because now these servers need to communicate with one another. They need to coordinate whatever they are doing. So that takes up a lot of overhead. That takes up a lot of time, and yeah, it's basically, if you have two servers, you'll probably get like 1.5 to 2 1.5, 1.6, 1.7 times the performance or something like that. So your job as a distributed systems engineer would be to try to get the maximum possible performance if you add more servers. So I hope that makes sense. Does it make sense? Does it make sense? Okay. Yeah, okay, I think a few people are responding. Cool. Now, just because you had one server before, now you're really rich, your startup is huge, you're getting all kinds of funding. Does this mean you add 10 servers and be done with it? No. If you jump from one server to 10 servers, it's not automatically going to work. You need to evenly distribute the load, so that something like what would happen is, if you don't do this properly, only a couple of your servers will get a large amount of load and the rest will just sit down, sort of like doing projects or something, in school. Just a few people are working really hard and the rest are just having the time of their life. So you don't want that. You want to distribute the load effectively, evenly. Synchronization among servers. This is what I talked about before, that all of your servers should be kind of in sync. Now, this idea is kind of hard to explain without getting technical. So I won't, I'll just stop here. Your servers should be able to, they shouldn't have any disagreements, and they should be able to coordinate with amongst themselves. And the last point is really, really interesting. So failure handling. Let's say, as I said, you have 10 servers now. You should design your system in such a way that even if a couple of servers from those 10 servers fail, your system should still be operational. And that's kind of a mind-blowing idea, if you ask me. That you have 10 servers, a couple of them just fail, they just crash or something, and your system still works because the remaining 8 will take up the additional load. They'll share the load of the servers that crashed. So this is something that you should incorporate into the design of your distributed system. And yeah, this is one of the very interesting fields of computer science. So let's move on. Does anyone have any questions?
Rohit, we do have 2 questions in the chat from your previous question break.
Okay.
If you just scroll up a bit in chat, I think Yajat says, "Hey, I have a doubt," and then Snehal also has a question.
Okay, I'll answer Snail's question first, and I'll then go to Yajat. Are these data centers safe? Safe? Okay, safe enough. Yes. It's actually, yeah, you kind of have to trust these companies with your data, but the general idea is that it's safe because even the US military and the CIA and I think the Department of Defense and all of them, even they run their software on these platforms. So they have billions and billion dollar deals. So I think it's secure enough. If governments and militaries can trust them, we can definitely trust them. And if they start snooping in your data, that's not good for their business. This is a huge business for them, and I don't think they would do these kind of things. So does that answer your question, Snehal? Snehal, right? Yeah.
What if our data gets mined?
What if your data gets mined? Can you repeat, please?
Means I heard about the data mining, so.
Oh no. Data mining is a completely different thing, and I will be talking about data mining. Is this you, Rajat?
No, I'm Kaustubh.
Okay, Yajat, you'll have to type in your question. Kaustubh, I will be talking about data mining, and it's a completely different thing. I'll be talking about it in the further slides. Okay, Yajat, can you type in your question? Okay, I'll just take your question the next time. Okay, just leave it there for me.
He's asking, can you hear me? No, we cannot hear you actually, so you'll have to type it in.
Oh yeah.
But I think this is going to take a while. Okay, Vaishnavi has a question until then.
Okay, for some servers to work, even if others don't work, so what additional features do we need to add? Well, there needs to be some sort of coordination between your servers. The rest of your, each server should be able to detect if the other one has failed, and if it has failed, it should be able to take up its load. So it's kind of there are techniques to do this. It's a lot. It's beyond the scope of this session, unfortunately. I'm afraid I don't have a straightforward answer to, what additional features do we need to add. We can talk about this offline. Does the gibberish and the original destination have a relation, or the code is random characters? It's random. It has nothing to do with destination. Okay, that destination thing was just an example. You can encrypt anything. You can encrypt your name or whatever, your password. It could be anything. There's no relation between the data and the gibberish. Does it ever happen that all the servers are not working? Well, that would be disastrous. And distributed systems engineers have to, I don't know, this is Arnav's question. That would be disastrous. That usually doesn't happen. And if that happens, you're in a bad place. You need to take care of that. And people do take care about that. How these servers are communicated. They typically communicate over networks, seaways, satellites, yeah, whatever. They use hashing techniques for encryption. Hashing is different from encryption. But okay, Deepa is unable to see the slides. Can you join in from a different device? Okay, I think I'm going to move on. I'll take the remaining questions later. So did I miss any slides in between?
No, I think this is
No.
just a connection issue. We can like just continue.
Okay. So,
Rohit,
uh-huh.
there's one question in the chat, like right now.
Okay. How does the server understand what gibberish means? Oh, okay. There's some intense mathematics going on behind the scenes in order to make that happen. Again, I would have to get really technical about it. There are keys involved. The server and the app would have the same key, and hence they're able to encrypt and decrypt with the same key, and hence it can make sense of the gibberish. Does that answer your question? It's a bit more technical than that.
How many people can use one server at a time?
It depends on the server. A server can serve, a typical server would be able to serve like thousands and thousands of requests every minute or every second. Yeah, every minute. They're pretty powerful, these servers. Okay, I'm sorry guys, I'll have to proceed. We'll try to answer your questions in the next Q&A break or at the question and answers in the end. So let's talk about backend development. Is everyone mute? Just hold on. I'm hearing someone's. Okay, cool. So let's talk about backend development. So in the very first slide, I talked about how the server needs to perform a lot of tasks like, finding a driver for you, finding a vehicle, finding a taxi for you, calculating your fare and planning the most efficient route. And well, all of those tasks need to be actually, coded by somebody. These things need to be implemented. The software for that, programs for that need to be written, and all of those programs will then run on the server. So all of this comes under what we call backend development. This is because all of this stuff is happening behind the scenes, so it's called backend development. And this basically deals with all of the business logic, like handling user registration. So when you sign up, it needs to verify your identity, save your name and password and your details to the database, and payment handling. And backend development is a broad topic, and this is another area with which a lot of people start off with. So yeah, this is backend development is all of the software that runs on your servers. Let's move on. I think there are a few questions in the chat, and I will get back to those. So let's talk about some really hot topics in computer science, and this is getting really popular these days. This is rather really popular these days, and it's machine learning. And this is something that Uber and Ola use behind the scenes. But before we get into how they use them, I want to talk about machine learning itself. Okay. And before we get into machine learning, I want to talk about how we as humans will learn. So, when we are born, we don't really understand the environment, right? If you were to take a baby on the street and point to a car and ask the baby what that is, I bet the baby won't be able to say car. The baby doesn't understand that it's a car. But as you grow up and as you see your environment, you see so many cars and so many different vehicles that you start learning, okay, this is a car, even that's a car, even though these cars might look different, or they may be different cars, you may look at them from a completely different angle or something, but we are able to recognize cars, we are able to recognize buses, we are able to tell cars and buses apart. So the point I'm trying to make is that as we see more and more things, we sort of learn from all of these examples about, let's say, how to recognize a car. This is not something that we are born with, but something that we learn from experience. We learn from examples. After looking at many examples, we are able to detect these little patterns in what we see and perceive. And that's kind of the same idea that machine learning uses, because the reason machine learning and we're talking about this is that you cannot actually write programs for everything. For example, if I ask you to write a program and which looks at an image and tells whether or not that image contains a car, you can't write a program for it in the traditional sense. Now, again, this is kind of hard to appreciate this idea, but you've got to trust me here. You cannot write a program to identify a car in a picture. The reason for that is because we cannot give a proper definition for what a car is. I mean, I can say, a car has four doors, it has an engine, it has four wheels, it has a window, but but each car has these things in a different way. So, an Alto and a Maruti Alto will have a different door from a Volkswagen Polo, or a Tesla Cybertruck looks completely different. But yet, as humans, we know that they're still a car because we kind of see the similarities in the patterns, and we are able to recognize those patterns. And hence, for tasks like these, if we were to make computers perform these tasks of like identifying uh, cars in a picture, or recognizing someone's voice, we need machine learning. We can't just explicitly write a program for that. So what we do is we sort of, it's similar to the baby example that I just gave. What you do is you provide the program with lots and lots and lots of examples. So let's say you're the car example. Let's say you're writing a program which can tell whether or not a picture contains a car. So what you would do is you would give the machine learning program lots and lots of examples of pictures of cars, and you teach it to find patterns in these images. And once it has seen a sufficient amount of examples, and then you give it a new example, it will look for those patterns, and it will be able to identify, and it will be able to say that, this looks like a car. I have definitely seen these kinds of patterns before. I can say with like 80% confidence that this is a car. And that's the basic idea behind machine learning. Instead of explicitly telling a program how to reason about an image or something, you provide it with lots and lots of examples, and it will learn through those examples. It's similar to how people learn. We learn through examples, we learn through experience. And that's the basic idea behind machine learning. And I've been talking about the example of a picture of a car, but the same idea can be extended to other kinds of patterns. So for example, voice recognition, or a lot of phones these days are able to recognize your face, or again, making stock market predictions. This is kind of interesting. So based on how the stock market has behaved in the past, you can feed all of that data to the machine learning program, and based on all of that experience, it can make predictions about the future. So it will be like, okay, maybe based on the past metrics, this is what I think this is how the stock market will behave. So this is kind of the idea behind machine learning. And this is an extremely hot field in computer science. And that's the reason I'm kind of really emphasizing this. This is what a lot of people are interested in. The possibilities here are literally endless. There's a lot of research going on, and this is just really, really interesting. So, oh, by the way, I wanted to talk about this. So this image is of a deep neural network. This is a program which mimics the behavior of the human brain. So it's kind of interesting. So how does machine learning work for these taxi services like Uber and Ola? So they use it for predicting what kind of demand they're going to be seeing. So right now it's COVID-19. No one's using these services, so that their demand is probably down. But in regular situations, they would be able to look at past experiences and forecast what their demand is going to be like. Dynamic price adjustment. If you've used Uber, they have something called surge pricing. So they change their prices depending on the current situation. So again, that they do using machine learning. I'm just going to have some water. Okay, just give me a second. Okay. So yeah, scaling up and down as per demand. So we talked about cloud computing. So if the demand is kind of low for taxis right now, maybe maybe Uber can just reduce the number of servers they're using and save some money. Finding the best route, they can look at the current traffic conditions and try to predict how much time it will take for you to reach a destination, and based on that, they'll find the best possible route for you. Customer support. We have so many complaints when we use applications. So instead of employing people to sit down and talk to customers, you can have bots which can which can interact with people using natural language. Calculating estimated time of arrivals. This again kind of deals with the traffic and everything. setting financial goals. They can use past experience. And this is the most interesting part. This, I think, is probably the pinnacle of what machine learning can do. It's self-driving cars. So Uber has their huge self-driving car project, and they use computer vision. So they have cameras and sensors on cars, and they can identify objects in their environment, and they can make decisions about how the car should go. It's all really, really, really interesting. So machine learning is hot. It's a hot topic. And a related topic to machine learning is data science. So these days, we have pretty much every app and service that you use collects a huge amount of data from you. So, for example, this Uber might be collecting data about how the kind of speed the driver is driving at, or the speed at which the driver. A lot of metrics. They basically collect a lot of metrics. If you're using other services like, let's say, I don't know, YouTube, and YouTube might be making a note of where you're clicking, which videos you're watching, how long you're watching them, are you skipping the ads? They collect all of this data in order to make more sense of how you're using their service. But just having all of this data, just collecting all of this data and just having it sit there makes no sense. So the point is that data by itself is useless. Even though you collect a lot of data, it doesn't produce it won't produce value for you immediately. It is of value only when you are able to make extract some knowledge out of it, extract some conclusions out of it. And the reason I'm talking so much about data science is because this is literally one of the hottest jobs right now. This is considered This is considered to be a really prestigious jobs, and people are getting paid really, really good for this. And it's a really interesting field. So as a data scientist, what you do is you take all of this data and you use statistics and machine learning and all of these mathematical tools, and you analyze this data. You try to extract some meaningful information from it. You try to extract some knowledge from it. Okay, so that it's not just some raw data. It actually gives you something of value, and usually this something of value is tremendously useful for businesses. Because just think about this: if YouTube is able to understand what you like better on their homepage and what you are more likely to click on, it means more business for them, because they'll be able to feed you more ads. And that's the reason companies love data scientists. That's the reason they're getting paid really, really well. And it's an extremely interesting field. So Uber uses data science. Uber, Ola, all of these apps use data science for like setting financial goals. We talked about this: dynamic pricing, demand forecasting. So based on the previous experiences, previous data, whatever they've collected, they can change their app or their algorithms, their software for the most profit. That's the basic idea. So before we proceed, I'm going to take a few questions. So
I think Dave had a question. Is
Okay.
CAPTCHA hard-coded? If you scroll up.
Okay, CAPTCHA hard-coded. No, it's not hard-coded. I think it's generated on the fly. I don't exactly understand what you mean by hard-coded. Okay, someone else is asking something. Is data science all about big data? No. Big data is when you have basically a huge amount of information. So just imagine Google. I gave the example of YouTube. If YouTube starts collecting data about where you're clicking on their website, it's going to generate a huge amount of data, because a huge amount of people use YouTube. And in that case, you would have to use these big data techniques where you have to like store a lot of data and efficiently sort of work with it. What are the reasons of not making an app which considers both the prices of Uber and Ola taxis and then compare provider? Blah, blah, blah. Okay, yeah, that can definitely be done. I don't see why that won't be possible. But Uber and Ola should let you do that. That's definitely a good idea, though. What are some things that machine learning hopes to achieve in the future, but we aren't quite there yet right now? So yeah, I talked about self-driving cars. Atharva has asked this question. This is a good question. It's an evolving field. It's only become possible to do machine learning practically quite recently, like I would say about a decade or so, or maybe less than a decade ago. And we are at a very, very primitive stage right now of machine learning. So I talked about self-driving cars, and there are multiple levels to self-driving cars. So right now, the kind of self-driving technology we have, you still need a driver on the seat. Even though the car is driving by itself, you need someone just on the driver's seat just in case someone goes wrong. So we have to go a level above where you don't even need that driver. So that's one example. And maybe you need there are other things like natural language generation. So it's when computers are able to come up with natural language. So maybe something that sounds very human instead of like maybe one day you just tell a computer, hey, write a resignation email for my boss, and the computer will be able to come up with a really human sounding email. uh, does normal Android programming, Advait, okay, let's just do this. Does normal Android programming involve backend development by default because that involves writing code, which is behind the scene case? No, the okay, I don't exactly understand what you mean. What writing code which is a behind the scene case? What does that exactly mean? I'll come back to your question. Please just clear my doubt. Vedang is asking, but we can't say that the
Rohit,
data. Uh-huh.
just a sec, before you proceed, there was another question that you might have skipped. Deepa
Oh, at the top.
asks,
Oh, sorry.
in data science, what does fingerprinting mean and how is it used?
Oh, I think data science and fingerprinting. I think it means that you're able. See, these apps, as I said, are collecting a lot of information about you. So a fingerprint, a real fingerprint, means it's something that is unique to you. So I think in data, what you're referring to is that in all of that data that let's say Uber collects, if from that data they're able to identify you, that like, okay, this piece of data is coming from Deepa, then I think that means a fingerprint, and that shouldn't happen. You shouldn't typically be able to map the data to its origin, the origin being you. So I think that's what you're referring to. That, to the best of my knowledge, that's what you're saying. But we can't say that data is useless, right? Because by that data, it decides what ads should we see or suggest. Yeah, but if you're just collecting all of that data and just storing it somewhere, it's useless that way. If you're actually running some data science stuff on it, so to speak, then it becomes useful. So data by itself is useless, but when you start extracting information, analyzing it, then it starts producing value. Then it's not useless. Does machine learning and data science have applications in other fields of science? Oh yeah. These are really, really general ideas. Machine learning and data science, they are useful everywhere. Just to give you an example, I attended this conference recently, and I think the engineer was from I forget the name of the company. I think he was from MathWorks. These are the people who make MATLAB, and he was talking about how they are using machine learning to I think monitor, or you know what. Yeah, it's a huge discussion in itself. That will take up way too much time. How about you write about this to me, and I'll get back to you over email or maybe in the Q&A session. Okay,
Can these data be leaked or hacked?
Can you repeat that, please?
Can these data be leaked or hacked?
It depends on the company. It can they take a lot of precaution to store it as securely as possible. So see, there's always a chance of something getting hacked, but you have to take the
Zoom?
What do you mean?
What about Zoom, as recently its data has been leaked?
These kind of things keep happening, and these companies operate at such a huge scale that they have to take these measures. They can't just be careless about data. So yeah, some of those companies, I think Zoom is a bit shady with their practices, but in general, they take the utmost care to keep your data as safe as possible. There can always be some vulnerability that hackers come across and exploit it. So you need to be constantly on your toes when it comes to securing data. You need to always employ the best possible practices so that you're always you're at peace. Your mind is at peace that the data is secure. Okay, these are a lot of questions. Okay, Manali, what do
Rohit,
you
I
say?
think we can probably save some of these for the Q&A session if this is disturbing your flow.
Yeah,
Or if you want to talk to them now, you can, of course.
I think we'll save this for the Q&A. Okay, these
Yeah,
are
we'll do
okay. Cool, guys.
that. Is that okay with everyone who's asked
okay?
questions?
These are a lot of questions, and we can just it will really disturb the flow. So let's just keep on going,
Yeah.
and we'll answer that
Okay,
towards the
cool.
end.
Yeah.
All right. So we're done with data science. Let's talk about databases. A lot of people have been asking about how information is stored. So databases are just a way to store all of this information. Now these on the face of it, databases might seem like a really, really simple idea. They're just storing data. What's so great about them? This is actually a really, really interesting topic because if you think about it, your data, all of the, let's say your Instagram, and you're storing your data, or let's say your Uber, you're storing all of the user information in a database. So that database should be secure. It should be really, really robust. And if you take up computer science, this is one of the most interesting subjects that you'll ever come across. It's really, really interesting. There's a lot to databases, and unfortunately, I won't be able to get into too much detail here, but I'll talk about basically the kinds of databases you see. So there are two major kinds of databases. One is relational, and other is non-relational. So relational databases are sort of like your Excel sheets. I think everyone has used Excel here. They're just tables, and you have, let's say you're storing information about a person. So you'll have columns like name, age, date of birth, I don't know, gender, stuff like that. And in the rows, you'll fill up the actual information about people. So that's basically how relational databases are. And you can have multiple tables. You can link them to each other. They're they are basically like Excel sheets, but they're far, far more sophisticated. And you have non-relational databases, which do not have this table-like structure. In fact, they typically don't have any structure at all. You are free to select the kind of structure you want. So they can be a bit more flexible, but they're also not as efficient as relational databases. So Uber uses MySQL, PostgreSQL, React, Cassandra, Hadoop, and Redis. And Ola also uses a pretty similar set of databases. These, again, on the face of it, databases might not seem all that interesting, but they do some really, really interesting stuff behind the scenes. They do a lot of heavy lifting for you, and they're pretty incredible software products. Let's move on to programming languages. So we've been talking about all of these things. And by the way, oh no, it's fine. I did cover that. So let's talk about programming languages. We've been talking about so many different things in computer science and all of these different ideas. And the thing is, you need to actually write some code to get these to working, to bring these to life. So all of that is obviously done using programming languages. Some of the popular ones, I'm sure you people have at least heard the names: Java, Python, C++. This weird thing, this is not C#, this is C#. JavaScript, there are many, many, many more programming languages. I've just mentioned the really popular ones. You can, this is what a lot of people start off with. I started off by learning Java. This is how I got into computer science. And yeah, learning languages is really, really interesting. Now, you can obviously, and when you get into computer science, you will be learning at least a few programming languages. And you can either do that, you'll obviously have to learn, but you can also get into actually making programming languages themselves. So there are people, obviously someone has to make these languages, right? You can't just, like, they don't just grow on trees or fall out of the sky. So people design languages. They design them so that it's easier for you as a developer, as a programmer, to write code. They make sure that your code runs as fast as possible on your machine. And this last point, maintainable. This is actually something really interesting. When you're working on huge software projects, you want to write, people typically want to write like really smart code and really, code which is not immediately, clear what you're trying to do. There are many people write code like this, which is like really smart, really efficient, but you don't really understand what it's doing. So what you want to do is write maintainable code. And this is another thing that programming language implementers or the people who design programming language try to do. They try to make sure that their language produces maintainable code. And one last thing that I would love to mention is that all of these programming languages, Java, Python, C++, we have so many of them, but obviously your processor is running all of these programs, but in fact your CPU, your processor, doesn't understand any of these languages. Java. Okay, someone has their mic. Yeah. So your CPU doesn't understand any of that. The only thing it understands is a really fixed set of instructions that are there. So these are like really basic, like add two numbers or subtract two numbers or move this stuff from here to here or something like that. So what we need to do is programming language designers, they need to come up with things called compilers and interpreters to actually translate this Java, Python, C++, JavaScript code into this instruction set. And in fact, it's happening right now. We are using Microsoft Teams. This thing I think is mostly written in a language called TypeScript, and it is being and there is an interpreter called V8, which is translating all of that into your CPU's instruction set. And that's kind of incredible, right? Your CPU understands only one thing, and that is its instruction set. All of these languages, all of these have to be translated somehow. And I think this is also a really, really interesting field of computer science. So we've covered a lot of ground here. We've covered a lot of things, a lot of different subfields of computer science, and there are definitely far more out there like bioinformatics and such. But we haven't really talked about the very essence of computer science, if you will. All of these fields, while they are really important, they don't really talk about what computer science is really all about. So I had promised you that we have memes, and here are some memes. So yeah, all of these fields are all nice and good, but everyone gangsta until the real gangsta arrives, and the real gangsta of computer science are data structures and algorithms. And I hope you like that. I think that's pretty hilarious. Do you like that? Okay, only two people like that. Come on, guys. Come on. Okay, I'm going to move on. So data structures and algorithms. Before we get into what data structures and algorithms are, I want to briefly talk about how a computer basically works. Okay, this is really stupid, but this is like the basic idea of how a computer works. You have some input, you give it to the computer performs some processing on it, and it produces an output, right? Input, processing, output. Now, how does this actually work in your computer? Well, all of that input is stored in your RAM. These are your RAM and the CPU are like the fundamental resources in your computer. Everything, I mean, yeah, you have all of these fancy graphic cards and multi-core processors and SSDs and whatnot, but your CPU and RAM, your computer cannot function without them. And these are the absolute core stuff. These are the fundamental resources within your computer. So all of the input that I talked about in the previous slide, it's stored in your RAM, and then your CPU performs some processing on that input, and then we sort of it performs some operations on that, and then we get the output. So okay, this is what I was afraid of. So this slide is messed up. Hold on. Let me just. I did try this in the afternoon and it was showing up as mess. I'll just open up PowerPoint and I'll show you the actual slide. This is just sad. Okay. So guys, this is the actual slide. So even though these CPU and so yeah, the basic idea is that these resources are limited. CPU and RAM are limited. I know today's CPUs are really, really fast. I think, is everyone able to see this? Yes, thumbs up, thumbs down would be great. Cool, okay. So I'm going to jump back to the slide. Okay. So even though today's CPUs are really, really fast, you have multi-core CPUs, 8 cores, 12 cores, whatnot. And even though they're running at like 3 gigahertz, 4 gigahertz, each of those operations that you perform on your input still need some time. And it's always a good idea to have fewer number of operations so that your program will execute faster. So fewer operations are always better. And even though our computers have like several gigabytes of RAM these days, even phones have 8 and 12 gigs of RAM these days, it's still limited. It's not unlimited. So making efficient use of it is really, really important. So I'm going to jump back to the original presentation. Huh. Okay. Can everyone see this? So yeah, we want to make the best possible use of CPU and RAM. So here's where data structures and algorithms come in. So data structures are basically a way of organizing your data in memory and you should be able to access that data really efficiently and modify it really quickly. So if you want to make good use of RAM, you should use the best possible, most appropriate, most efficient data structure for your data. So some of the common data structures are, an array. An array is just a list of, in this case, it's a number. It could be a list of names of people. Another really common data structure is a tree. If you think about it, you have files on your computer, files and folders. So let's say you have a folder at the top, and that folder contains a lot of files. So those are sort of, it's sort of a tree structure if you think about it. Your folder will have some files and more folders within it. Those folders will have more files and folders. So it's kind of forming a tree structure. So your files are actually stored as a tree on your disk. Hash tables are one of my favorite data structures out there. They store key value pairs. So an apple is red, a watermelon is green, a banana is yellow. This is a hash table. So data structures are really, really important. The way you organize your data in memory it can make a huge difference. And algorithms are how you perform a certain task. I cannot emphasize this enough. Algorithms can make or break your program. Literally, they're that important. So an algorithm, if you've never heard this word, it's just a sequence of tasks that need to be performed, a sequence of steps, if you will, that need to be performed in order to accomplish a task. So for example, if you want to make tea, the first task would be to grab a vessel, pour some water in it, add tea leaves, and obviously keep it on heat, add sugar, let it boil, and then serve it. So it's an algorithm that's an algorithm. That's how you make tea. That's the task. So in computer science, an efficient algorithm would have as little tasks as possible so that, you can accomplish as little steps as possible so that you can accomplish your task faster. So some examples of algorithms would be, searching for an element in an array. So let's say we have this array, and we want to search if the number 12 exists in this array, and it doesn't. So searching and sorting, you can even sort this array. Searching and sorting are some of the most fundamental algorithms. Finding the height of a tree. So the height of the tree is sort of the longest this path that you can follow along the tree. Find the shortest path between two locations on a map. This is what we've been talking about throughout this session. If you, for Uber and Ola, if you have two destinations, if you have 2 points on a map, your location and your destination, you want to find the best possible, shortest, most efficient path. You need algorithms for that. You need efficient algorithms for that. Finding relevant websites based on a search query. You open up Google, you type in a query, and Google literally scans the entire internet and hands you your results. So they're obviously using some really, really efficient and smart algorithms behind the scenes in order to serve you your results so quickly. So again, I'm going to say this one more time. Data structures and algorithms are really, really important. They are at the very heart of computer science. They are the essence of computer science. And just to drive the point home further, just to sort of hammer it into your head how important they are, I'm going to show you an example. I think everyone here knows what a GCD is, greatest common divisor. I think everyone has learned this in school. I'm going to compare two algorithms for calculating GCDs of extremely huge numbers. And when I say extremely huge, I mean like 100-digit, 500-digit, 1,000-digit numbers this huge. And we want to do that as fast as possible. So I'm going to compare two algorithms, an inefficient algorithm and an efficient algorithm. Now, before I get into this, you might ask, Rohit, well, why the hell would I ever need to calculate GCD of such huge numbers? Well, we talked about cybersecurity and how we have these encryption and decryption algorithms. Well, turns out that one of these algorithms is called RSA, and it depends on the fact that we can calculate GCD. It requires us to calculate GCDs of extremely huge numbers. So we need to calculate GCDs in order to do online payments, or talk to your friends securely on WhatsApp, or have this encrypted video call right now. Calculation of GCDs is important. And I've put up this code just so you have something to look at, but I won't be getting into the code, don't worry. So let's just compare these algorithms. This inefficient one, even for 20-digit numbers. Now, 20-digit is rather small. I said we need an algorithm for like 100 or 500, 1,000-digit numbers. Even for just 20-digit numbers, this algorithm will take thousands of years. Do you have 1,000 years to wait for your payment to process, or your message to reach your friend? This would be nice. Thumbs up, thumbs down would be nice, guys. Do you have 1,000 years? Are there any of you magical creatures? I don't think so, right? No one has that kind of time. This is extremely inefficient, and we can definitely do better. So the efficient algorithm, in contrast, it takes just a blink of an eye to find the GCD of 500 or even 1,000-digit numbers. Just look at the difference. It's staggering, right? This is the difference between you being able to send a message securely to your friend and not. So yeah, algorithms are really, really important. This difference is just huge. And you need to be really smart when you're designing algorithms. So I'm going to say this one last time. Data structures and algorithms are at the very heart of computer science. They are the essence of computer science. And that's pretty much it. But before I go, I want to share some tips if you're going to take up a career in computer science. This is one of the most hyped up fields out there. There's a lot of hype surrounding computer science, and I don't want you to get lost in the hype when you take this up. Don't just follow the hype. Don't just be like, okay, machine learning is really hot right now, so I'm only going to focus on machine learning. That's not how it works. You need to understand the basics, dabble with everything in this field, and find your niche, find your real interest. Don't just go with whatever is popular. Another thing is, don't just learn technologies, learn the principles behind them. So, Android development is good. It's a technology. It allows you to write apps really simply. But try to think of how those apps actually, how the app is actually displayed on screen. There's so much within Android that is making all of that possible. This is kind of hard to explain without getting technical, but a lot of people just use these fancy tools and technologies and try to build products, and that's just sad. Try to understand the basics, the principles, the fundamentals, and you'll have a great time as a computer engineer. Don't chase the next shiny thing. Well, this is all, people keep saying that computer science is a rapidly evolving field, and every day there's something new, and that's true to a certain extent, but also kind of false, because if you understand the basics of something, learning these changes every day is not going to be hard, because it doesn't evolve that fast. People just keep doing things in a slightly different way, and they make a big deal out of it. But if you know the basics, you won't be intimidated by these new things. And this point, this is pretty much one of the core reasons why I even wanted to conduct this session. CS, computer science, is not just programming. Yes, programming is a major part of it, but CS by itself is not programming. This would be like saying CS is programming would be like saying that maths is about writing equations. Is it? It's not, right? It's definitely not. It's just a means to an end. It's just a way to express your ideas. What matters are your ideas. So computer science is not just programming, it is logical and analytical thinking. You're presented with a problem and you should be able to, reason about it, think about it logically and analyze various solutions to it. It's problem solving. It's showing your creativity through problem solving, and that's really the core of computer science. And you might think that ha kaitari was bara, I'm just saying some nonsense here, but as you sort of mature through this field, this is what you'll slowly realize. And if you start off with this mindset from the very beginning, it will really, really help you. I promise you this will help you, because a lot of people just get lost in these first 3 points. They just, they go for the hype, or they just learn some technology and don't focus on the basics. But if you are good at problem solving and, thinking analytically and logically, if you're creative, computer science is the field for you. And all of these things, if you do these, this is basically what separates mediocre engineers from the really brilliant ones. These big companies like Microsoft and Google, they're notorious for their tough interviews. And these tough interviews don't deal with, whether or not you can use some fancy tool or technology, or, you can program in this new programming language. No. They focus on the basics. They focus on these things. The fourth point that I mentioned here: logical thinking, analytical thinking, problem solving, and creativity. That's what they always try to find out, in their interviews. I've been through Microsoft's interview process, and I'm telling you, this is it. This is the stuff that separates mediocre engineers from the really brilliant ones. And yeah, that's pretty much it. So thank you. I hope you enjoyed this session.